Welcome back to the course on audio signal processing for music applications. In this second week of classes, we are talking about the discrete Fourier transform. And in this lecture demo, I want to put that in practice by analyzing a sound. In particular, I want to analyze the sound of a tuning fork. Okay, a tuning fork produces a very clear tone. This is why it's used to tune other instruments. And it produces a very clear frequency. So let's try that. Let's analyze it. So we will open Audacity and we will hit the record button. And with the microphone, we will record the tuning fork. Okay, that should suffice. Here now let's delete the parts of the recording that are not the tuning fork. And let's hear it again. Yes, that's the tuning fork. Maybe let's select the loudest part. Okay, and let's zoom in. Okay, to check if it's really like a sinusoid, we can zoom in to the end, and yes, it looks like a quite nice sinusoidal looking function. When we presented Audacity, we mentioned that we can visualize the spectrogram, which the spectrogram is basically a time-varying DFT. So this is the time-varying DFT of that sound I recorded of the tuning fork. And clearly it shows a very strong line around 500 Hertz, which is basically the frequency we are hearing. In fact, this tuning fork, if we look at the device, it says that it produces 440 Hertz. So this must be the 440 Hertz frequency. However, we also see other horizontal lines, which means that there's also other components that are present in this sound. So in order to analyze it a little bit more deeply, let's save the file. Maybe before that, let's clean it a little bit more, and let's make a fade in at the very beginning and a fade in at the very end. That always helps to be heard and to be analyzed by other programs. And now let's export it. This is a sound that was recorded at 44,100, and it's a mono file. So this will create a .wav file, and we will save it under tuning fork name. Okay, there was one there. Okay, and now we can go to the SMS tools through the terminal, and it's in the software directory, models interface, and if we type Python models GUI, we will start the interface that includes all the models we will be using. And the first one is the DFT. So let's go get the sound that we recorded in the home directory, and it was the tuning fork. Okay, and now let's hear it. Okay, now let's with the default parameters, let's analyze it. Yeah, that's clearly a fragment of the input sound. This is the DFT of that sound, the magnitude and phase spectra. And then we do the inverse DFT, and we get this shape that is also very much, apart from a smoothing window that we have applied, it's very much like the original sound. And here clearly we see a peak in the magnitude spectrum, and if we put the cursor, it shows that it's around 440 hertz. Okay. But also we see other components, softer, but that they're also present. Maybe to check how a real sinusoid is analyzed and how it's looks like in the DFT, in the spectrum, let's open up a sine wave that has been synthesized. So in here in this directory, I have a sine wave at 440 hertz. Okay. Okay, that's a sine wave at 440 hertz. It clearly sounds very similar to the tuning fork. And now let's compute it. Yes, it's similar shape, but if we compared in fact the two spectrograms, they look a little bit different. The one of the tuning fork looks clearly more noisy than the one of the electronic sinusoid. Still, the electronic sinusoid doesn't look ideal, but it clearly looks with a very clear peak, and the rest looks much softer than in the diapason in the tuning fork. Okay, so with that we can analyze sounds, and of course we can change the size that we analyze. So for example, if we, instead of 511 samples, we take 1001 samples and we compute it, now we are taking a bigger chunk to be analyzed, but basically the spectrum looks a little bit different because of course we have more samples, but the general shape is the same. And we can play around with the parameters to visualize different parameters. For example, we can just, instead of starting at 0.2 seconds, we can start at second 0.5, so a little bit forward in the sound, and the sound looks very much the same because of course it's a pure sine wave and it's always the same sound. And that's all I wanted to say. Basically, we have used Audacity to analyze the sound of a tuning fork, and then we have saved the file and used the interface available on the SMS Tools package that we have developed to analyze the DFT and compare the result of the DFT of this tuning fork with the one of a pure electronic sine wave. Okay, this sine wave, it's in Freesound, so you can get it there. And that's all for this class. Hopefully this has given you a practical view of what the DFT can do with real sounds, and also try to understand what a sinusoid is. And that's all. I hope to see you next class. Bye bye.